Alright, let's cut to the chase. The goal of this video is to teach you how to create effects. By the end of this video, you will be able to receive an input from the user and return that input with an action alongside creating and destroying effects, including emitting and enabling effects, which we will cover in two separate ways. And if you're not here to learn and you're here to copy code, I suggest you go find another video. The point of this video is to teach you how to program. Nothing else matters, right? So just getting the code to function is not going to get you at a better spot than you were before this video. So I suggest you take your time, be patient. You're going to get frustrated, take a break. Because at the end of the day, you're going to be able to understand concepts and functions and things of that nature that you didn't grasp or understand before. That is my hope with this video. Anyways, without any further ado, let's get into the tutorial. All right, so I tried doing one recording of this and it was a catastrophe. So this time around, hopefully it goes better. So first things first, we're going to need to, we need two effects, one effect that emits and one effect that enables. Now me personally, I'm gonna hit that control copy button. You can literally find any dust effect in the toolbox and use that. I'm gonna literally open up my effect and you can see I have a part, and inside that part is an attachment. You don't need that. All you need is a part and the particle emitters. Those are the only things you need. And now these effects are gonna be our effects that we enable. I literally got this Akari effect from the toolbox, and then I went inside his torso, grabbed this dark aura and just slapped it inside of a part, and I call it the part dash aura effects. Very simple, nothing complex about it. I'm gonna resize it really quickly. I rotated the part 90 degrees and then I stretched it on the what is this, the Y axis a bit, just like big enough so that like if I was to put it on top of my player, that it would you know, cover most of his body. So yeah, so now we have our effect that we're going to emit, we have our effect we're going to enable, and we need to add these effects to some place we can access in our code, right? You can't just throw things in workspace and then call them for use later. I mean, you can, but it's not a good idea. So we're going to do replicated storage. Replicated storage, I'm going to create a folder for it. I'm going to call this FX. I'm going to create another folder inside that. It's going to be called VFX. And we'll create another folder inside that, another folder inside that, and then another folder inside that, and another folder. Sorry, I kind of got lost there. So after the VFX folder, we create one more folder, and that's going to be called our dash effects folder. And that's where we're going to put the dash aura and dust effect. I'm going to copy them and Control Shift V the objects into our folder, and now they exist there for us to reference. Now that we have a place to reference our effects, we are going to go to our starter player, starter character scripts, and we're going to create a local script. In that local script, I'm going to title it player dash. Right, because we're gonna I want the player to dash. That's gonna be the action that they're gonna do. So we're gonna need to do a few things. We're gonna need to request a few services from Roblox, because there's a few things that we're gonna need to do that we currently don't have access to just by default. The first thing is the player, of course. So we're gonna create a variable called local player, and to access our player, me, we're gonna do game get service players dot local player. Now this is going to be us, and we know this because if I do print player and then I press play, it's going to get the player, which is me, and it's going to print player. Now, this observable value undefined, literally no idea what this is. Might be this guy, might be this dude. I'm not sure where this is coming from. The most important value thing that I want to point out here is that Nightwinger underscore 500 is my user. That's me, the player. And if you were to do it, it's going to be your username because you're the player, right? So that's the point of that. Then we're going to do a few more services. Local rep storage is what I'm going to be calling it. It does not matter what you call it. You just need to be consistent with your naming. The next thing we're going to need run service. And that'll be for basically running actions, like multiple actions over and over again over a course of time. Game. And then if we want to destroy something, we're not going to outright destroy it. We're going to use something called debris. So game, you get the basic idea, right? I'm just not a fast typer. So we're going to do some reference. I'm going to call this references. And we're going to reference a few things. So we're going to make a local for our FX folder called FX folder. Doesn't matter the name again, but what matters is what we do here. So we're going to do rep storage .fx. Now, I could also just do this. Oops, I don't know what I just copied and pasted. We could literally do this. It's the exact same thing, but notice how much more characters you get to type here compared to this. It's just a time saver, so it's good to make sure you're getting your references. You're requesting your services and doing these little references that I'm about to do because it's going to save you time in the future. Same thing, we're going to do equals fx folder dot vfx. Oh my goodness, I'm forgetting one of the most important things. User input service. Sorry, that slipped my mind. But we're gonna need to do game get service user input service. Oh my goodness, input service. Now, we're actually gonna use this right now. Now, user input service is basically how we get the input from the player. So we're gonna do UIS. It doesn't matter the name. I'm just calling it UIS because I don't like typing out user input service every time I want to use user input service. So we're gonna do input that began, and then we're gonna connect the function. We don't have the function we're going to use yet, so it's actually kind of pointless. But let's make the function. Local function. So it's gonna be called, and we're going to get two inputs, two parameters, and that's going to be input, the input, and we're going to get the keyboard. We're going to get keyboard. And we're going to connect user input button, and we're going to print the input, and we're going to input keyboard when we print. So what this is going to do is basically anytime I click here, or if I was to type on the keyboard, it's going to say that we input an object, right? Input object. And it's also going to tell us if we were accessing the gamepad or the keyboard, right? Now I call it keyboard, it doesn't matter what you call it, but it's technically called the gamepad. So if I'm typing here, you can see true, true, true. So something that we could do here is, let's say I only want the code to work if I'm not typing on the keyboard, like I don't want it to like check input. So if keyboard equals true, then return, and then print the input dot what is it called? Key code. Oh my god, I knew it was key something. There we go. All right, now it should work. So if we are typing, if we're not typing in the keyboard, it's gonna tell us the key that we're pressing. If we click on our mouse, it's gonna say unknown because it's not a key code. But if I'm typing in chat, it's not gonna work. So, you know, that's good to know. And then it goes back to normal. Now that we can get an input from the player, that also means that we can check certain things about that input. It doesn't matter what we're returning. And okay, so I'm not a comment guy. I don't like adding a lot of comments, but it helps for the tutorial to have comments. So after this next part, I'm gonna skip to me adding a bunch of comments, and then I'll explain, right? But now that we're able to check specific inputs, now that we know how to do that, we can do something like if the input, I hate that name. I'm sorry, I gotta change the name of it. If input, I'm gonna call it input. If input dot key code equals enum dot key code, which I mean we're just comparing a key code, and I'm gonna say Q. It doesn't really matter what you want the key code to be. Then print dashed, right? And let's see what happens here. Dash, 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 and then when I'm pressing keys right now. You can literally see me moving around, but I'm not pressing the Q key, so it doesn't matter. But I am pressing the Q key now, so the dash is going up. Okay, so I've added my comments and I actually changed something, but it's not important. I want to emphasize this. This is the exact same as keyboard. Just make sure your names are consistent. But if it's keyboard, if it's gamepad, it doesn't matter. You could call it Bob. It doesn't matter. It doesn't. What matters is the order in which you're putting it. So this is the second input, and this is the first input, and then we're using that second input here, and then we're using that first input here, right? And you may be wondering, where are we even getting these from? What is the input? What is the gamepad? How do we know which is which? This is an event, right? The UIS input began, and this is an event. And events have certain parameters that are recorded, I guess you could say. They get you certain values, right? And when you connect a function to it, it's going to connect those values, right? In our case, it's the input object, which is just like information about the button we input, and then the game process event is the second parameter, which is basically just checking to see, okay, did they interact with like UI, or did they interact with something that actually exists in the game itself? Is it internal or external? Now that we have that, we have all the setup that we need to be able to have our player dash, right? In my case, I guess I say in my case, we're going to be using something called apply impulse. You can use linear velocity if you want to, but for this tutorial I'm going to be using apply impulse just because it's so easy and very, very simple. Instead of printing dashed, what we're going to do is we're going to need to get the HRP, because the HRP is where we're going to be impulsing. Now to get to the HRP, we're going to do something where we get the player, the character. The character is the thing inside the game, the thing you control. And then we're going to do find first child, and we're going to do, and then I think that shouldn't throw an error. I'm going to double check that. Yeah, okay, that doesn't throw an error. Nice. Okay, so now we're going to use humanoid root part. We're going to do dash strength, how far we want the player to travel, and we're going to set that to like 200 something. Now we're going to do HRP apply impulse, and then we're going to do vector3 dot new, and then we're going to do, let's do 1 0 1 x y z. Y is up, x and z are your 2D planes. So we're gonna multiply that by 200, or not 200, by dash strength. Now let's see what that ends up looking like. That shouldn't throw up an error. Maybe it's not strong enough. Let me try making this 2000 maybe. There we go. Now we're dashing. Look at that. But we're only dashing in one direction here. We're not going anywhere. So instead of doing 1, we're instead going to do HRP dot velocity dot x, and we're going to do the same thing here. hrp dot velocity dot z. Now what this means is it's going to, oh my god, send us flying. So we can go back to 200 now. What this means is we're going to travel in the direction that we are currently moving towards on the z and x planes, right? Which is really nice, really cool, right? But there is a small error that I want to touch up on. But this isn't, the point of this isn't to make like the perfect dash system or anything like that. But the point of this is to make something that looks relatively functional while at the same time being very simple to understand, right? And you can see here with some testing, we learned that if you jump in the air and then we dash, we actually go a lot farther, right? So then if we do it on the ground, and that's because apply impulse uses friction. So if you are going to use apply impulse, you got to be careful of that. There's a few ways of going about this, but the simplest way of going about this is by checking to see if you are touching the ground. So we need to get the humanoid. So let's do local humanoid, and it's the same setup basically. Actually, I did this wrong. If humanoid dot floor material equals enum dot material dot air, but then basically this is saying if the humanoid is touching the air, right? Then we're gonna do that. But I'm gonna add an else statement, which is basically just saying if the humanoid isn't touching the air, then blah blah blah, right? If the statement isn't true. So if they aren't touching the air, then we're gonna do this. If they aren't, but if they are, we're gonna do this, but we're gonna multiply. And this step is very important. You have to put it in quotations, and then you have to do minus whatever value you want it to be. I'm gonna do minus 100. And you may be wondering, why did I put it in quotations here? And that's because Roblox does math in PEMDAS, as you should probably be doing math as well. But basically it's multiplication then division, or multiplication and division left to right, and then it's addition and subtraction left to right. So it would try to do, it would do the multiplication first, and then it would try to subtract 100 from a vector, and a vector is three different numbers, and you can't do that. So it would throw an error up. But because we didn't do that, we're able to dash, and if I jump in the air, we go pretty far still, but it's not like crazy farther than when we're on the ground. So I would say that looks pretty good. That works for this video, so we're not going to be really touching that anymore for this video. Now we're going to be focusing on creating effects, and we're going to be focusing on getting those effects to work. First things first, we need to create the effects. And to create the effects, we simply need to call them something. So what do we call it? What are they called in replicated storage? Okay. So I'm gonna call it dash aura effects. And I'll call this local dash dust effects. And we're gonna do equals. We called it dash effects dot dash aura effects. And we're going to call this dash effects. Oops. Oh my goodness. Dash effects dot dash dust effect. There we go. But we need to make sure we do clone. Hi, Editor Knight here. I forgot to clone the second effect, as you can see on your screen right now. I only cloned the first effect, so make sure you do that. I figured it out later in the video, but I'll save you the headache. Make sure you do that, and I mentioned this later on as well, so yeah, but make sure you do that. Back to the video, because clone makes it actually exist. Right now we're just referencing it, but with clone you're creating it. The issue with this is when we create the effect, you'll see here that we don't really see the effect. We don't see it exist. It's not being created, right? Technically it is being created, but we just can't see it because it's not a part of our view. So you could do something like dash aura effects dot parent equals workspace, and what that does is it makes it a parent of the workspace, which is what we're in. And we can see here that the effect is being created. You can see it there, but you can see it's not there. Where is it? And the other effect that's supposed to be there, it's gone too, right? That's because the effect is not anchored. If I was to anchor the effect, where is it? If I was to anchor the effect, then it would not fall. Like, look at that. That effect exists, but our effect falls still, right? We're creating it and it falls, as you can clearly see. So to fix that, we could do a few things. First of all, we want it to be on our player. So I could do dash aura effects dot position or position equals hrp dot position. I might have to do cframe dot position. I don't think I do though. So look at that. We're creating the effect, but it just falls down, right? Same error, same issue. Now to solve this, we need to have the position be constantly updated, not just one time. And we can do that by using run service. Now, I like to have everything organized and done with this in a function. So we're going to do it like that, all right? So the first thing that we want to do is we want to create the function. And the function, it doesn't matter the name per usual, but we can call it something like enable effect follow. And with enable effect follow, we can do something where we get parameters or inputs that we can use in our function. The things that we want to use is the effect itself. We want to use the object that we want it to follow, object to follow. We want the length that we're going to be following the object for. The enable delay, or the delay, well, I guess effect delay before it becomes disabled. Maybe I could call it disable delay. And then we're going to have a boolean that checks to see if we're destroying the effect. So destroy effect bool, and then we're going to do destroy effect delay. That should work for now. And actually I'm going to just call it destroy effect, and then yeah, that should work. So with this, I mean, we could check a few things. We could do if effect equals nil, then return. And we could do that. Oops. I mean, you can't do it like that, but then return. And we could do that for like a few objects, or object to follow equals nil, or length equals nil. Like if we don't give these values, then we're just going to return. And then we're going to say, we could do print one of the first three inputs are nil, right? Yeah, you could probably and should probably do that for any of these or all of these, but I'm not going to. I don't feel like it. And we're just going to move on to what we're actually here, the meat and potatoes. So remember, we do this, which is kind of important, right? We need to parent it to the workspace and get the position, set the position to the object to follow, but we're going to do that in here. So effect dot parent equals workspace. And I guess it's now as a good time as any for me to tell you why we're doing it like this. You know, sometimes we're doing equals and sometimes we're doing equals. Equals is a comparison. So we're saying if effect is equal to nil, then do that thing. Effect is equal to. This is equal to. This is equal to. Two different things, right? This is saying this thing is that thing now. And this is comparing if this thing is equal to that thing, or comparing that thing. Comparison, setting, right? We're setting the parent to workspace in that case. Now that we have done that, we now need to set effect dot position equals object to follow dot position. Now that's going to not work, as you can probably guess, because that's literally the same thing that we did before. We need to do something a little bit more with our code here, and that's using run service. So we're going to make a variable, and we're going to call this local follow rs, right? And that. And we're going to do run service dot render stepped connect. And then again, I did the thing. I forgot to do the thing, but we need to make a function. That local function, we can call it anything, but we're going to call it follow object. And now we're going to connect the function follow object. And now basically what this is saying is every few ticks, we're going to be running this function, right? We're going to be running follow object. So if I paste this here and then I go in to press play, we're going to see where, oh, I'm so goofy. I forgot to actually use the function. So this is called enable effect. So we're going to do enable effect follow, and then we're going to do, let's do dash aura effects. And then we're going to do HRP, and we're going to do, let's say, 2 seconds. If I press play, we can see that the effect follows us now, which is pretty good, right? But it looks a little goofy because it doesn't follow our orientation or a rotation, I mean. So to fix that, we're going to do something with C frames. Remember how in this function, in follow object, we do effect.position equals object to follow.position. In our case, we are going to do effect.cFrame, which allows us to not only control the position of the object, but also control the C frame. So we're going to do effect.cFrame is equal to cFrame.new, because we're creating a new C frame. And we're going to let the position be the same. So effect.position. And we're going to multiply that by object to follow get pivot dot rotation, right? So it's gonna get the pivot rotation of the object, and with that, look at that, it follows us, and the effect doesn't look too shabby, right? Doesn't look too good either, but I mean, it's not really the goal, is it, right? And if I really wanted to, I mean, I can change it and then replace it in replicated storage if I wanted to, but I don't really want to. It doesn't need to look amazing, but it works. Awesome, right? Cool. Now we need to do the very same thing, but for our emit effect. But actually, before we do that, there's something that I just realized. The effect doesn't delete. So that's kind of important, and we need to acknowledge that. So first things first, we want the effect to disable after a certain amount of time, right? I'm going to go to dash aura effects, and I'm going to set the transparency to 0. So it's going to look like this in game. It's going to look like a giant block. It looks a little goofy. But what we want to do is we want to do task.delay. Now, why are we doing task.delay? You may be wondering. And the answer is quite simple. I just think it's a better version of task.wait. Task.wait, my biggest issue is when you use task.wait, it literally pauses every code, all the code that comes after it. All of the code in this function is going to get paused until after. What if I want the rest of the code to run? What if I only want like a little subsection of the code to pause and I want the rest to keep going? That's what task.delay is for, right? So we want to wait the disable delay length, and then we're going to use a function, right? And inside this function, we are then going to disable the effect. And to disable the effect, we're going to need to use a loop, and I'll explain that shortly. But for now, we're going to do the same thing. We're going to do task.delay, and we're going to do length. We're going to use a length function, boom, bam. And then after length, we're basically going to disconnect the run service, the render stepped. So we're going to do follow RS, disconnect. Very simple, right? After the length, and the length is 2 seconds. So I'm going to add 1 second to that, and let's see what happens, right? So I dash, and boom, the effect stops following us, and the C frame is not going to be the same anymore. So it just kind of stops, just stops. And then the next thing that we need to do is we need to make that effect, like I said, stop emitting first. To make it, I just kind of wanted to, I'm gonna change the transparency back to 1 because I just wanted to showcase that the effect is following us. But the next thing that we need to do is we need to make the effect disabled. So we're gonna do a for loop. For, I'm gonna have to make a large amount of comments. Oh my god. For loop, and we're gonna do effect num effect name in effect get descendants do. We're going to do if effect name is a particle emitter, then effect name dot enabled equals false. Now that's kind of confusing. Don't worry about it because I'm going to explain it very shortly once I add all my comments. But let's just see what happens. So if I dash, I'm going to wait a second, and then it disappears. You see that? You see that? Isn't that awesome? And with that, you know, we have working VFX. But there's a really big downside of doing this in VFX style that I would like to cover. I feel it's very important to know. So, you know, with this VFX style, you know, the effects are smooth, man. They're created and deleted smoothly. They follow the player very accurately. I don't have any complaints here, right? But I'm going to switch my screen to show you something, like I said, very, very important. Okay, and what you're looking at here is player 2. So right now I'm looking at player 1, and if I was to dash, you can see here that the effects appear on my player 2 screen here, but the player 1 only sees me dash. And if I was to do the same thing on this screen, you can see here that the effects appear on player 1 screen, but not on the player 2 screen. So I'm going to explain that briefly. So when you create an item on a client, right, it is created, but only on that client. So technically the item isn't even created because it does not exist, right, on the server. And if it's not created on a server, then other players are not going to see it. Only the person who created it is going to see it. And that's a good thing. So like hackers can just create items and then like, oh, look at me, everyone, look at this big object that I created. However, that's a bad thing, obviously, when we want people to see the items that are created. The rest of this video is going to be set up for the part 2 of this tutorial. And in part 2, I am going to cover server-sided effects and client-side replication. Both of those are solutions to this problem, which is other players not being able to see the effect. And I want to preface this by saying you do not need to watch the remainder of this part to be able to follow along with part 2. We just covered things like server-sided cooldowns and using remote events to accomplish that. So if you already know how to do those things, you can go on to part 2 whenever that releases, which should be like within a day from this video. But yeah, otherwise, if you are sticking around, then let's continue on with the video. And if you are leaving, have a good day. Because the effect isn't just like disappearing. Like if I was to make this like 1 and I made this 5, the effect is going to stop following my player, and it's gonna go back to where it's gonna be like go away. I think it's actually falling. Yeah, you can see it fall. Look at that, it just falls. But because we have the effect delay or whatever, the effect gets its chance to like end. It just looks better. It just looks better. To keep it simple, it just looks better. Okay, I've added comments now. So basically what we're doing here at the top is we're checking to see if we're missing the effect, object to follow load length, and if we're missing any of those, then we're going to return the function and just stop this entire function. It's just going to, nope, we're not doing it anymore. But if we don't find those things, if we don't have those errors, then we're going to parent the effect to the workspace so we can see it. And then we have this function here that I'll explain shortly, but we're going to be running that function every tick through run service, follow rs. And inside follow object this function, we're going to be setting the effect position to object to follow. And then we're going to be setting the effect C frame to its new position and also the object to follow rotation, which we get by doing get pivot. Then we also have disable delay. Now disable delay is it waits. We wait for disable delay to happen. Delay. Oh my goodness. We wait out that timer. This is basically doing task.wait, but everything's just going to be inside of one thing. And once that time has been reached, we're going to basically go through each effect and we're going to disable that effect. And then once the length has been reached, we're going to disconnect this run service, and then basically we're not going to be running this function anymore. So it's not going to be constantly setting the position to the player, which is what was causing it to follow the player in the first place, right? So let's see what that looks like. See, it follows us and then it gets destroyed. Well, it doesn't get destroyed, but then it stops following us, right? Which is pretty cool. I think that's pretty awesome. Now, the last thing we need to do is we need to destroy the effect. So we're going to do if destroy effect. No. If destroy effect. And we don't have to do equals equals true. This is the same exact thing. Literally the same exact thing. It doesn't matter. It's like this is the exact same thing as multiplying. They mean the exact same thing. but moving on. But moving on, if destroy effect, then we're gonna do task dot wait destroy effect delay, because I don't want to add anything after it. But you can do task dot delay here. It doesn't really matter. But I guess because we have been using it consistently, I mean, we might as well use this function. Boom. And then we're gonna do after task effect destroy effect delay, it's going to use debris. So the debris add item, which I know is weird, but add item is basically we're adding the item that we're gonna, you know, manipulate, and then the time before we destroy it, right? Which would be that. And actually, we don't need this. I'm an idiot. So we probably want to do this. This is what we want to do. And this is going to throw an error if destroy effect delay is a shorter time than length. It's going to throw up an error here. So I'm going to put, I will want to put this in under length. So it's going to be under here, right? So after just the length function, we're going to do if destroying the effect, if we're supposed to. All right, there we go. So basically what we're doing here is we're just going to wait the length of the effect, and then after that we're going to add it to debris. And debris is going to wait whatever the destroy effect delay number is, and then we're going to destroy it. But that's only if destroy effect is true, which is it's a boolean. So we're going to do let's say true, and then let's say 3 seconds. So it should be 1 2 3 4 5 6. Is that right, math? 1 2 3, yep, 6. Okay, so this should be 1 2 3 4 5 6. All right, so this should not throw up an error. And if we go ahead and dash, we create the effect, it's there, and then it's destroyed. It's not there anymore. Isn't that awesome, right? Pretty cool. I guess the last thing that we would need to do is add comments, but I already added comments. So now we can move on to the next function, which would be for the dust effect. Now the dust effect is a little bit different because we want the dust effect to follow the player only on the ground, because it really makes sense for us to get dust when we're like in the air, right? So we're gonna first make the function, and then we're gonna put the function in a place that makes sense. And then we're gonna have it be similar but different. So effect object to follow, and then we're going to do length. We're gonna do emit num. We are gonna do length still. Then we're going to do emit delay. And then we're going to do destroy effect and destroy effect delay. I'll explain these in a bit. I just explained them and I just sounded stupid. So again, we can do this like little if effect equals nil thing, blah 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 blah. It's not really that important. It's more for double checking your work. But I guess I'll add or emit num equals nil. But we're gonna do, it's gonna be very similar. Effect dot parent equals workspace. And then we're going to need a function which is going to set the effect position to something. And what we want that to be is, I don't know, let's just do follow object again. Follow object. Oh, I messed up. Equals workspace. There we go. And we're going to make this local function because it doesn't like us making functions by itself. And we're going to do... So if you have this bug, I'm sure tons of people are not going to watch this part and it's going to be frustrating, but I forgot to do effect.position equals object to follow. You have to do this before you do anything else in the script. So make sure you do that. Make sure you do that before I continue my explanation. We're going to do for emit num, emit name in effect. And then we're going to do get descendants, sorry. And I do get descendants and not get children, because get children, like in dust effect, it would only get the attachment here. But we want the children inside of the children. Anyways, we we want to get the effects inside of the object, right? Regardless of if they're actually directly children or if they're grandchildren or something like that. So that's why we do get descendants. And then if emit name is a particle emitter, then what we're going to do is we're going to emit the effect. So we're going to emit, we're going to do emit name, emit, and then we're going to do the emit number, which in this case, let's just do emit num, right? Now, the issue with this is this would literally crash your game, because you are, if we do what we're going to do, which is make a run service, this would literally crash your game, because every single tick you're going to be creating an effect, creating a particle every single frame. This is going to crash the client. So we need to add a delay into this. So first we're going to do follow rs equals run service dot render steps connect, and we're going to connect it to follow object, similar to what we did before, but we need to add a delay. Now that delay, I'm going to make it a boolean, right? And that boolean is going to be called local can emit, and we're going to do if can emit, then we're going to do if can emit equals true, is equal to true then, and we're going to put this in here. But we're also going to add can emit is equal to false now. So now this statement's not going to happen, right? And after all of that, we don't want to put this inside the loop because it's going to be doing this repetitively. But what we're going to do is we're going to do task dot delay. That's why I love task delay, because it's not going to pause the script or anything. Task dot delay. And this is where we have our emit delay. And we're going to do function, boom, bam, bop. And we're going to set can emit equal to true after waiting the emit delay. And now this should not give an error, I don't think. So that should be good to go. And then we also need to account for the rest of the stuff. So the length and all that crap. So task.delay, you already know. For a majority of this recording, I've been editing out these like segments, but I felt like it was important to keep this like inclusion in. It's literally just me sitting here thinking to myself, like I haven't edited out the audio or anything, but a lot of programming is literally just comprehension, just thinking about what you're doing and understanding, does this make sense, does this not make sense. I'm not going to do this again, but I felt it was important to include. Actually, I want to see if you guys understand what's going on, so try to do this yourself without following the tutorial. This isn't very complicated. We just did it with the other function, and if you can't do it, then reference the other function or just skip ahead. Shouldn't take very long, right? Okay, so I only added the comments, and then I added the disconnect, right? So just like last time, we disconnect the function after the length has been weighted, and then we check to see if we're destroying the object before we add the item to the debris. Now the last thing that I forgot to mention, this is very important. So if you have this bug, I'm sure tons of people are not going to watch this part, and it's going to be frustrating, but I forgot to do effect.position equals object to follow. You have to do this before you do anything else in the script, so make sure you do that. Make sure you do that before I continue my explanation. We're going to call this emit. We're going to call this effect num, like it should have been called in the first place, and this is going to be called effect name. And we're going to change these effect num, and there we go. And I'm probably going to edit it so that this is fixed, because that's kind of a really bad oversight on my part. So sorry about that. Sorry about that. But we get every particle in the effect, we emit it, and then we wait task.delay before we can emit again, right? And what this does is it kind of it prevents us from, you know, causing a memory leak or anything of that nature by creating too many objects too fast for the script to handle. And again, we're going to do something very similar, but because remember we want it to be only when we're on the ground that we create the dash effect, what we're going to do is this. Emit effect follow. We're going to do dust dash dust effect HRP. We're going to have it follow for, let's say, 1 second, and we want the, honestly don't remember, it's the emit number. Let's have it emit, let's say 5, and we want to emit for like a second, and then we want the cooldown to be, it doesn't even have to be a big number, it could literally be 0, 0, 1. And then we're going to do destroy effect, let's say after 3 seconds, or after 3 seconds. And that should work. Might give us an error, we'll have to see. Oh, would you look at that? I mean, it goes on for way too long, and it takes too long to destroy the effect. Actually, there's a few things. The effect itself, I think, is enabled. So that's the first error. That's a logic error. If you want to get specific, that's a logic error. So there we go. Uh-oh, dust effect not. Where did that error come from? Oh, you see the issue here? We forgot to clone it. So that's what I was talking about before. You have to make sure that you clone the effect. So there we go. We create the effect, and we can keep creating the effect, but it's at the wrong spot in the body. So instead of doing it there, we can do so instead of humanoid root part, we could do player character find first child. Now this is where we might defer here. I'm doing R15. So R15, it's called, like if I want to do right leg, it would be right, I would have to specify right lower leg. But I think in R6 it's like it's right leg with a space in the middle. That's not, I messed up. Let me see. I actually have my player right here, so I can just grab it really fast, and that's a good thing. Look at this guy. So in R, it's called left leg in R6. So if I was to use an R6 character, I have to type it like that. But because I am R15, right lower leg, did I not type it like that? Right lower leg. Oh, I'm stupid. Okay, I did do it right. I just didn't connect it. There we go. It goes on a bit longer than it needs to, but it gets the job done, right? So I'm gonna mess around with the values a little bit, and then I'm gonna come back to you with something that looks better. Just realized I stopped my recording. But what I've done here is I made the emit number 10, and I made the length 0.3 for the dust effect, and I made the enable effect 2 for the length, and I made the disable delay 0.3. So if I wanted to come into my project, we can see here that the effect is created. It looks pretty cool. If I zoom out, you know, it looks fine, and I zoom in, it looks okay too. And the little aura is created anytime we dash. But specifically, when I dash into air, we only get the air effect, right? I mean the aura effect, because that effect is created no matter what. But this effect is only created if we are not in the air, right? Okay, so that covers most of the client side. Give yourself a little round of applause. You know, you've probably learned a lot, especially if you're a beginner here. And if you're not, even if you're not a beginner, you did a lot. I mean, it's 129 lines of code. The next thing that we're going to do is we're going to make a cooldown for our effect. Now, it would be pretty easy to make it a cooldown on the client, and we do need a cooldown for that reason that you just saw on screen. But we want to be careful with how many things we do on the client, because the client is kind of not trustworthy. It's not something that you should give full jurisdiction of things like damage or cooldowns. Try to limit it as much as possible, right? You have to make sure that you're not giving full trust to the client. So how do we go about that? Well, first things first, we're going to need to make a server script. Now to do that, we're going to go to server script service. We're going to make a script, and we're going to name this script dash, let's call it dash server. Seems like a pretty fine name to me, dash server. And we're also going to need a remote event. Now to make a remote event, we're going to come to replicated storage. We're going to make a folder. In that folder, we're going to call it, let's call it remote events. Not very creative, but just call it remotes. And then inside remotes, we're gonna add a remote event. I don't know. Dash remote, I guess. And now we need to reference a few things. So just like with the client script, we need to reference replicated storage. So we're gonna do game get service, and we're gonna reference our remotes here. So we're gonna do remotes. And I'm just gonna do dash remote. I'm not gonna reference our folder. Equals rep storage dot remotes dot dash remote. And with that, I'm not sure if we need anything else for the time being. So we'll see. We'll see later on. I mean, it's not important, right? We're gonna do local. We're gonna do variables, and we're gonna need local on cooldown, and that's going to be a table, and I'll explain what tables are later. And we're going to do local dash cooldown length, and that's going to be equal to, let's say, 2 seconds. So now we have all the things we need here. So first things first, we need to have something that's ran when we want to do a function, right? And that's going to be called, that's what our remote event is for. A remote event basically is like a way to connect our client to the server or a server to the client. We can have things where we fire the server or fire the client, and that action is what we can be used to communicate. So for example, we can do dash remote dot on server event connect function, and then we can print player, and then we're going to put in player. And then on the local script, the local side of things, we're going to open up user input button. After the player has input this key and the effects have been created and whatnot, what we're going to do is we are going to, first we need to reference the remote event. So we're going to do local dash remote equals rep storage dot remotes dot dash remote, and then we're going to do dash remote fire server, and that's it. So after we dash, we're going to fire the server, and boom, look at that. Nightwinger 5100 is printed in the server. So the server knows that the player is me. In that regard, right, you may be confused because we reference player here, but we don't reference player here. And that's because when you fire server, the game, remember what I talked about with default parameters, right? Like with input button, we automatically get input in gamepad. Very similarly, on the fire server, we automatically get the player, right? Because they assume you probably want the player name, just like they assume you probably want the input, you probably want the gamepad. Those are things you probably want, right? So yeah, we get the player, which is awesome, right? But now we're going to use that player for something very important, and that's going to be for checking cooldowns. So we're going to do if player, sorry, we're gonna have to do a loop. So for player num, and then player name in player, and on cooldown, sorry, on cooldown, do if player name equals player, then print player found, and then we're going to do return. It's just that simple. And if we return, then that means that the rest of this code isn't going to get ran. So we can do print player not found, and then we're going to do something where we do table dot insert, and the table we're going to insert is cooldown, and the thing we're going to be inserting is player. So we're going to add the player to the table if we can't find them, but if we do find the player, then we're going to not add the player. So player not found, right? Player found, player found, player found, player found, because the player exists in that table now, right? And I think it actually might be helpful if I do print on cooldown. So it starts off as an empty table, and then when we add the player, now I exist in that table, right? And I'm not going to get added anymore because I'm already in the table. But you may be wondering, what even is a table? What the hell are you talking about? And a table is an array, basically, right? And if you don't know what that is, think of a table as sort of like basically like, all right, I'm gonna cut that guy off because he's just starting to ramble, but basically arrays very simply are just ways for us to store and find information. We can check each array, in this case, or every player, from 0 to 1 to 2 to 3 to 4, and so on, right? And every player, of course, is going to have a different name. And we're just comparing every player at every index to see if the player we're looking for is the same as the player name that's in the array. Hopefully, I didn't ramble too much there.
You did.
But moving on, right? Now, what we have this, right? And with this, I mean, it's literally meaningless because of two things. One, the player is never removed, and two, we can still spam the dash button if we want to. So yeah, to fix that, two things we can do. One, we're going to make a function, and that function is going to be used for removing cooldowns. So we're going to make a local function, which is, let's say, cooldown, right? You can tell I'm very creative with names. So with this, we're going to check to see, we're going to get a few inputs. So I think the first input should probably be the table. So we're going to do, let's do cooldown table, and then we're going to get the object, and then we're going to get the length. So with this, we're going to do let's say task.delay, and we're going to wait the cooldown length. So length function, done this several times before. And then we're going to do task or table dot remove, and we're going to remove the, what is it called, the object from the cooldown table. So the cooldown, and then the object to remove, and then we're going to print object has been removed. Very simple. And we're going to run this function after we insert the object. So we're going to do cooldown. We need the table, which is on cooldown, and then we're going to need the player, and then we're going to do dash cooldown length, right? So let's see how this works out, right? Player not found, and then I think I did something wrong. Oh, I'm sorry. So yeah, you can't remove specifically objects. You have to remove numbers, right? So we have to actually do a for loop here. Sorry. So let me remove this. For player num, I'm not doing this. I'm just gonna as soon as I typed it, I was like, I'm not doing this again. So we're gonna do that, and then we're going to do object name, object num, and then we're going to do cooldown table dot well, cooldown, no, we're gonna do table dot remove on cooldown table, and then object num, because you cannot just like say the name of the object you want to remove. You have to say the number of the object. You can see we don't get an error there, but we don't get anything there because I didn't print anything. Print so if we were to print this, boom, player not found, Nightwinger has been removed. But you can see it doesn't really matter. I can keep spamming this because it's just like, it's more hypothetical. This is a hypothetical cooldown. We're not actually disabling any actions at this point in time. We're just adding them to a table and then removing them. So to restrict movement like this, what we can do is make it so that we check a value. Now that value, I'm going to use attributes, and attributes I really like because it's an easy way to have variables that you can access and manipulate on the server that the client cannot manipulate. So to start, we're going to need to make another script, server script. Oh my gosh, keep calling it server script. I'm going to call this player data. And what we're going to do with this script is we are going to do, okay, we create the function and then we need to run this. We need to run an action every time a player gets added. So game dot players added. Game dot players added connect function, and then we're gonna do players, and then we're going to I'm being an idiot. Set attribute. Yeah, I am being an idiot. Okay. Set attribute can dash. There we go. Okay, so now if I was to open up players and then me, you can see here I have an attribute called can dash. And now we can use that in several places in our script, but most importantly, we can use it here. So when we insert the player, what we want to do is we want to do player set attribute. And that's what I really like about attributes, because we can do things where we can dash, where we can have access to a variable that we can access anywhere. We don't need a module for it. We don't need like anything like that. We can just have like access to this variable from anywhere, which I really do like. And it's also something that the player cannot just manipulate however they like. So we set can dash to false, right? Now, two things what we're going to do here. If player get attribute, we're going to get attribute this time, can dash is false, then return. If this is false, then return, right? Because we don't want to continue anymore. We don't need to see the rest of the script because we already know what's going to happen. This is just going to save us time and save resources from the server, from having to loop every single player in the game, right? Then the player script, what we're going to do here is if, that's fine, but we're going to do and player get attribute can dash true. And let's see what happens here. So we can dash here. We can still able to spam it. So what I did here was instead, I just made it so it says player get attribute can dash. So we get that attribute and then we check to see if that attribute, that boolean, is true. And then the same thing here. If this is not true, if player get dash is not true, you can also do if player get dash is not equal to true. These both work. Then we're gonna just return the function. I forgot a step. You didn't make a mistake. You're perfect and beautiful. Once we remove the player from the array, we have to set that object to can dash is equal to false. Oh, I'm an idiot. Okay, set it to true. Oh my god. Okay, there we go. Little brain fart. You probably were like face palming just reading that, looking at that. But now we have a dash that's on cooldown, and we dash, and everything works, which is pretty cool, right? So I'm going to add a comment, and then we're going to kind of go over what we did. Okay. So essentially, what happens here is we check to see if the player's attribute is true for dashing. Then we check every player to see in the on cooldown table to see if that player already exists in there, and if neither of those are true, then if neither of those occur, then we're going to add them to the table and we're going to remove their ability to dash, right? And then we're going to run the little dash cooldown, and then that's when they're able to dash again. I'm actually going to make this like, let's say 0.7 seconds. And yeah, and then on the server, the client side, all we do is fire the server, and then boom, the player's able to dash, right? So yeah, that's basically it. We did a lot in this episode. It's like an hour and 20 minutes at this point. Where we have the player dash here. and we have the player create effects, one enable effect, one emit effect, and that effect is destroyed, disabled, all of those things. And additionally, we even have the player here on a cooldown, right? We have them on a cooldown table, and we add and remove them to the table depending on if they are able to dash or not, right? So with that, I think that will conclude the first part. I want to say, because I mean, like, I feel like we covered a lot, and I don't want this video to be like 3 hours long. The thing is with YouTubers is they like to like drop one part. With Roblox YouTubers, they drop one part, and then they have you wait months, weeks, especially knowing me, right? So what I'm gonna do is I'm gonna record the next part immediately after this. Well, not immediately. I'm gonna go to bed and eat, and then wake up and then record the next part. But I'm going to edit both over the course of this week, and drop the videos 24 hours within each other. So the first part's gonna drop, and then 24 hours from now, the next part's gonna drop, right? So any questions or whatnot, I'll be happy to answer them. In the next part, we're gonna be covering effects on the server and effects using client replication. Now, why am I breaking this up into two parts? Because this video would be like 3 hours long if I didn't do that. And that's about it. Also, it's kind of late and I'm tired. So yeah. In the next part, I'm going to be covering why that happens. I'm going to cover server effects, and I'm going to cover client replication, and how you can use it with VFX to make your effects viewable on the clients. So yeah, if you enjoyed the video, you found it helpful, like, comment, all that other jazz. And if you found any confusion, or you have any questions, or you want clarification on why I did something a certain way, feel free to ask comments in below. I mean, I'll try to answer as many as I can. And yeah, without any further ado, I will see you guys in part 2. So, peace.